Okay, right now let's continue our topic on even and odd functions. Example 2. Prove that the sum of two odd functions is also an odd function. This is a proving. So for a proving, what should we do? It's the same as finding or determining whether the function is even, odd, or neither. So let's look at the first sentence I will put down is, suppose that f of x is odd, g of x is also odd, and the sum, let's say this one is h of x, equals f of x plus g of x. F of x is an odd function. We can put up, since f of x is odd, therefore f of negative x is negative f of x. Since g of x is odd, therefore g of negative x is negative g of x. H of x is f of x plus g of x. G of x. If we want to determine whether this one is even, odd, or neither, we plug negative x in for x. So we replace all those x with negative x. And we know f of negative x is negative f of x. And g of negative x is negative g of x. Both of these two terms have the negative sign, so we can take out the negative sign and leave f of x plus g of x in the brackets. And this one is h of x. So far, we can see h of negative x is equal to negative h of x. Then we can draw a conclusion to say h of x equals f of x plus g of x is an odd function. So the conclusion is correct. Okay, let's prove the other example. Prove that the product of two odd functions is an even function. I will still put down the latter statements. Let's say f of x is an odd, g of x is also odd, and the product h of x equals f of x times g of x. It's exactly the same as what we proved in example 2. This one is odd. It suggests f negative x is the same as negative f of x. And g function is also odd, which means g of negative x equals negative g of x. So h of negative x right now is f of negative x times g of negative x. And we know this one is negative f of x times, and g of negative x is negative g of x. So negative negative becomes positive. So the result is f of x times g of x. And this one is just h of x. So in this case, we can see this h of negative x is the same as h of x. Then we can say this function, which is a product function, equals f of x times g of x, is an even function. So this conclusion is also a correct one. Okay, example 4. Suppose f of x is an even function and g of x is an odd function. Determine whether the function f of g of x is even, odd, or neither. And we all learned what this symbol represents. This symbol is the same as f of g of x. Okay, let's look at the conditions here first. Anyway, f of x is an even function. So we say, since f of x is even, therefore f of negative x is f of x. And the g function is odd, since g of x is odd. Therefore, g of negative x is negative g of x. My new composite function, f of g of, okay, I need to plug negative x in for x. This one, in the first pair of brackets, you will see, okay, this is g of negative x. G of negative x is negative g of x. So I will replace this one with negative g of x. And this one becomes f of negative something, negative x. This x just becomes g of x. And this f function is even, so the negative is gone. It's just f of g of x, which means f of g of negative x is the same as f of g of x. So far, we can see this composite function is an even function. So this is our lesson on 2E, even and odd functions. This is the homework. If you have any questions, please let me know in class. Thank you.